Hello friends, welcome to Chembook. In this class, we are going to discuss about catalysis by organometallic compounds. Before going to that topic, we can discuss what are catalysts. Now, we all know about thermodynamically favorable reactions. These thermodynamically favorable reactions are slow at modest temperatures. But these such type of reactions are not of much importance in the synthetic purpose. So, by increasing the temperature, we can accelerate the rate of the reaction. But it requires very high energy and also it is very expensive. Then, this high temperature will cause side reactions and also reduction in yield of the product. Once again, I say, what do you mean by thermodynamically favorable reaction? These thermodynamically favorable reactions are slow at modest temperatures and these cannot be used in synthetic purposes. Why? Because it is slow. By increasing temperature, we can accelerate the rate of the reaction. But this is a high energy process and also it is expensive. And also this high temperature will cause side reactions and also reduction in yield of the required product. In this condition, we use a catalyst. So, what do you mean by a catalyst? Catalyst is a substance that increases the rate of a thermodynamically allowed reaction by lowering the activation energy of barrier for the process without itself being consumed. Now we can discuss some of the properties of a catalyst. Those reactions that are not thermodynamically favorable cannot be made favorable by using a catalyst. It does not affect the Gibbs free energy of the overall reaction. And the other point is that if several reaction paths are possible, a catalyst may increase the product specificity by lowering the activation energy for the desired path or by raising it for another. Then, a catalyst combines with the reactant or substrate to form the transition state, and then finally the desired product is obtained and also it regenerates the catalyst. A catalyst further enters the catalytic cycle and combines the reactants again and again. A typical catalyst can participate about 10 raised to 1 to 10 raised to 6 times in a catalytic cycle. Now consider the free energy profile diagram. In the case of an uncatalyzed reaction represented by this green, there is a high energy transition state. But whereas in the case of a catalyzed reaction, it contains multi-steps with no high peaks and no deep depression. So it is clear that a catalyst will decrease the activation energy barrier and thereby it forms the desired product. Catalysts are of two types. Which are they? They are homogeneous catalysts and heterogeneous catalysts. Now we can compare between these two catalysts. Firstly, we can consider homogeneous catalysts. These catalysts are soluble in the reaction medium and also these are more product selective in nature. This catalyst requires a low temperature, about less than 250 degrees Celsius. For homogeneous catalysts, the reaction mechanism is well understood. Here, the product separation is not easy and also the catalyst separation also not easy, that is difficult. This is an expensive process. Homogeneous catalysis is very expensive in nature. Here the product separation is not easy. That is, if a stable product is formed with the catalyst, then it will be the final product and the catalytic cycle will stop and it become very difficult to separate from the product. Now we can consider heterogeneous catalysts. These catalysts are insoluble in the reaction medium. and these are less product selective in nature. This catalyst requires a very high temperature, and also the reaction mechanism is not well understood in the case of heterogeneous catalysis. Here the product separation is easy. This is a great advantage of heterogeneous catalysis, whereas in the case of homogeneous catalysis, the product separation is not easy. So this is a disadvantage. Here the catalyst separation is very easy and they can be easily separated by filtration. This heterogeneous catalysis is very economic in nature. Here heterogeneous catalysis requires a relatively high temperature and pressure and frequently lead to a mixture of products. But its great advantage is that they are easily separated from the reaction products. Now we can study some terms related to catalysis. What are they? Catalytic cycle, turnover, turnover limiting step, turnover number, that is TON. Let us discuss one by one. What do you mean by a catalytic cycle? A catalyzed reaction occurs in cycles and are called as catalytic cycles. Here the active form of the catalyst is regenerated. A catalytic cycle consists of a series of stoichiometric reactions that form a closed loop. So what do you mean by a catalytic cycle? A catalyzed reaction occurs in cycle and are called as catalyzed reaction. And the active form of the catalyst get regenerated. And a catalytic cycle consists of a series of stoichiometric reactions that form a closed loop. Now what do you mean by turnover? Turnover describes one loop through catalytic cycle. This is represented by TO. Next we can discuss what is turnover limiting step. The last step in a catalytic cycle is called as turnover limiting step. Then the fourth one is turnover number represented by TON. Turnover number is defined as number of passes or turns through the catalytic cycle before the catalyst become deactivated. Turnover number, which is represented by TON, can be calculated by this formula, that is TON is equal to moles of reactant divided by moles of catalyst multiplied by percentage yield of the product. So turnover number can also be defined as number of moles of a reactant converted by 1 mole of catalyst or number of moles of product formed per mole of catalyst. Higher the turnover number, longer the life of the catalyst. Another term related to catalysis is turnover frequency, which is represented by TOF. What do you mean by turnover frequency? It is defined as turnover number per unit time. Now, turnover frequency can be calculated by this formula, that is TOF is equal to moles of reactant divided by time into moles of catalyst into percentage yield of product. In this equation, this part that is moles of reactant divided by moles of catalyst into percentage yield of product represents turnover number. So this equation can be rewritten like this, that is turnover frequency is equal to turnover number divided by time. Now the unit of turnover frequency is equal to time inverse. What is the unit of turnover frequency? Time inverse. Dear friends, in the next class onwards, we can discuss about some of the well-known examples of industrially important homogeneous catalysis reactions like hydrogenation of alkenes, hydroformylation of alkenes, Walker process, etc. Thank you all for watching this class.